Hello everybody, welcome back. This is just a continuation of the video that ended just minutes ago, to the point where I didn't even erase the board. This was number 20 on the homework. We still have page 280, number 20 and 27, 24 to go as examples, and that's what we're doing here. Here, what we're doing is discussing the convergence of this alternating series. And in order to show an alternating series convergence, you need two things. One, it's decreasing. Strictly decreasing. Every a sub n is greater than every a sub n sub 1. And then two, the limit of the thing, if it's equal to 0, that alternating series converges. So we have the alternating series convergent. Now what about the regular series, the positive series? What about? What is it? 1 over n squared plus 1. Does that converge? Does that converge? Well, I don't know. If it does, then this series is absolutely convergent. If it does not, then it's conditionally convergent. So let's test this one. I use the, looks like I use the limit comparison test. And I'm doing that because, oh, I'm sorry, this is the square root. No, I wasn't going to use it, now I'm using the limit comparison test. Because I can see this, as this gets big, it's kind of like 1 over n. So I'm going to choose another series. I'm going to choose another function, sequence to be 1 over n. And then I'm going to compare these, meaning I'm dividing the top one by the bottom one. So a sub n over b sub n is 1 over n squared plus 1 over 1 over n, which is n over n squared plus 1. And that's what we want to take the limit of. So now we're taking the limit of this. Whoops, this is square root, this is this, sorry about that. So we're going to take the limit of that, and the limit of this is 1, meaning that, well, from the limit comparison test, if 0 is less than that limit, and it's less than infinity, then this one you chose and the regular series either converge or diverge together. And we chose one that just so happens to diverge. And since 1 over n diverges, so does the series. So does 1 over the square root of n squared plus 1. That diverges. So the original series is conditionally number 20. Conditionally. Underline those in the quiz thing. Conditionally convergent. Oh, sorry about that. Sorry about that mess. Convergent. Okay. One more. Number 24. Boy, if I'd have known this was 2 tapes, I'd have done more. I'd have done more examples. But stop at number 24. What is 24? Is that a... Could be. Oh yes, this one right here. Sine n pi over 2 over n squared. No, n squared, right? We have to realize what's going on here. So I start writing down. I just start writing down what the heck this is. So for n equals 1, this would be 1. For n equals 1 pi over 2, is 1, and for n equals 2 it's 0, and then 1/9, and then again 0, and then 1/25, and then 0, and then 1/49, and these are negative. Every other one's negative. Because, well, let's see, n pi over 2. If you put a 1 pi over 2, sine pi over 2 is 1. So it's 1. You put a 2 pi over 2. That's sine of pi, which is 0. 3 pi over 2 is negative 1 over n squared. So this series is actually, oof, bear with me, negative 1 to the n. Now I want to represent, somehow I want that to be odd numbers down there. So in order to represent odd numbers, we're going 2n minus 1 squared. For n is 1, this is 1 squared is 1. For n is 2, this is 2 times 2, 4 minus, that's 3. For n is 3, that's 6 minus 1 is 5. So we're representing the odd numbers. And then what's up here? Just a 1. Because this is just going back and forth. So this is actually the alternating series, negative 1 to the n, 1 over 2n minus 1 squared. That thing, because of the nature of the sine of theta, just oscillates between 1, 0. 1, negative 1, 1, negative 1. And then with zeros in between. So, now, let's test it. Well, by the way, the hard work's over. You probably can see it right now. Or maybe you can, I don't know. So now, note, so we're testing this. Negative 1 to n times 1 over 2n minus 1 squared. We're testing that. All I'm going to do is mess with this one because I'm pretty sure that converges. Note, 2n minus 1 is greater than n squared. So therefore, 1 over n squared is greater than 1 over 2n minus 1 squared. And this one, and since 1 over n squared converges, so does 1 over 2n, so does just a positive series, the regular alternating series, 1 over 2n minus 1 squared. That converges. Hence, the whole thing converges. Hence, just write absolute convergence. Hence, absolute convergence. 8 minutes. Okay. I hope this is helpful. This is homework. More to come. Thank you much. See ya.